In the world of archaeology, discoveries are often slow, quiet, and buried beneath decades of research. But every once in a while, a single piece of evidence emerges that refuses to stay silent. In September 2021, one such discovery surfaced, not as a bone, a tool, or a ruin, but as a simple photograph. The image showed a human footprint preserved in what had once been the muddy floor of an ancient lake bed in southern New Mexico. On its own, the footprint might have seemed like just another trace of early life, but when scientists analyzed it, the result was shocking. The print was dated to 23,000 years ago. This was not just surprising, it contradicted nearly everything taught in classrooms across the United States. For more than 70 years, the dominant academic belief had been that humans first entered the Americas around 13,000 years ago, long after the peak of the last ice age. According to this long-standing model, the continent had been sealed off by towering, unbroken ice sheets covering much of present-day Canada and northern North America. These glaciers were believed to have blocked any human movement from Asia, making it physically impossible for people to reach the American mainland until the ice melted and opened a narrow passage called the ice-free corridor. The problem with the White Sands footprint was not just its age, it was the implications that came with it. If humans were present in New Mexico 23,000 years ago, then the entire framework of early American migration had to be re-examined. And even more intriguing, the footprint was not alone. Over time, researchers identified more than 60 human footprints, all preserved in clear trackways, all belonging to individuals who had walked the same ground thousands of years apart. These prints lay side by side with the footprints of extinct Ice Age animals, forming a living record of movement, interaction, and survival. White Sands National Park was already famous for its vast, bright gypsum dunes, rolling white landscapes that resemble snow even though rain is rare. But beneath those dunes lies the true treasure, the remnants of Lake Otero, a massive prehistoric lake that vanished when the Ice Age ended and global climates shifted. What remained behind was a flat expanse of mud-cracked desert soil, layered with sediments rich in fossilized traces of ancient life. The first person to recognize that something unusual was happening there was David Bustos, the park's resource manager. In 2009, he began noticing dark, shadow-like impressions that appeared briefly on the dry lake floor before being swept away by wind and weather. They were difficult to see, almost like illusions, only visible when the moisture levels of the ground were perfectly balanced, not too wet, not too dry. Bustos gave these fleeting impressions a fitting name: ghost tracks. He believed the site was hiding something important, even if the evidence disappeared before it could be studied. His observations eventually drew the attention of archaeological teams, setting the stage for one of the most important excavation projects in North American history. As researchers explored the lakebed more deeply, they began identifying footprints from some of the most iconic animals of the Ice Age. The land had once been a crossroads for enormous beasts that roamed the region during the Pleistocene era. Among the tracks were those of Columbian mammoths, massive relatives of woolly mammoths, with soft footpads that measured nearly 50 centimeters across. Their prints revealed details of their size, gait, and even weight distribution. There were also the footprints of Harlan's ground sloths, creatures that stood over 3 meters tall when upright, leaving deep, claw-marked, kidney-shaped impressions in the earth. Dire wolves, now extinct, left canine tracks larger than any modern wolf species. Ancient camel footprints, belonging to species that once thrived in North America before disappearing, were scattered across the surface. And perhaps most dramatic of all were the prints of saber-toothed cats, predators armed with massive elongated canine teeth that dominated the food chain before extinction claimed them. But what stunned researchers was not the presence of these extinct animals, it was the unmistakable presence of humans among them. Unlike bones, which can only tell us how a person died, footprints tell us how they lived. And at White Sands, the footprints began revealing stories that no fossilized skeleton ever could. One trackway, stretching for nearly a mile, showed a single adult walking across the muddy lake floor while carrying a toddler on their hip. Scientists could determine this from the depth of the print, which was significantly deeper on one side, showing how the additional weight shifted the person's balance. Along the trail, tiny toddler footprints appeared intermittently, marking the moments when the child had been set down, perhaps to rest or walk for a few steps before being lifted again. The adult's stride remained steady and consistent, showing familiarity, endurance, and purpose. When researchers followed the path in reverse, they saw something even more compelling. The same adult walked back alone, stepping directly into some of their original outbound footprints, meaning the return journey had been made soon after the first. This revealed not only movement, but intention. Nearby, researchers also discovered ground sloth footprints that crossed directly over the human path. What made these prints fascinating was that the sloth appeared to have risen on its hind legs at one point, as though detecting the human presence, likely through scent, before turning away and continuing in a different direction. This suggested not a confrontation, but awareness, proximity, and coexistence. By 2019, scientists were ready to answer the biggest question of all: how old were these footprints really? The first dating attempt focused on seeds of an aquatic plant found embedded inside the footprint impressions. The plant, a species of ditch grass, had grown in the lake when it still held water. When radiocarbon tested, the seeds suggested an age between 21 and 23,000 years. But this method sparked immediate controversy. Several scientists argued that aquatic plants often absorb carbon from lake water rather than the atmosphere. If the lake water contains dissolved carbon from ancient bedrock, it can make the plant appear much older than it truly is. This issue, known as the hard water effect, has misled archaeological dating before. Skeptics insisted that the White Sands dates were unreliable. Some argued that the findings should not have been published at all. Instead of ignoring the criticism, the research team accepted the challenge and went back to White Sands in 2022 with stronger tools and a more rigorous strategy. The next dating method focused on terrestrial pollen, microscopic particles from pine, spruce, and fir trees preserved in the same sediment layers as the footprints. Unlike aquatic plants, trees absorb carbon directly from the atmosphere, making their pollen immune to the hard water effect. The team collected an astonishing 75,000 individual pollen grains, an effort described by geologists as one of the most painstaking environmental sampling projects ever undertaken. When tested, the pollen confirmed the same age as the seeds, 23,000 years ago. But the team was not finished. They applied a third dating technique, optically stimulated luminescence, or OSL, to analyze quartz grains from the same soil layers. OSL dating doesn't measure carbon at all. Instead, it measures the last time quartz particles were exposed to sunlight. This makes it a completely independent clock, unaffected by water, minerals, or organic contamination. The OSL result pointed to an age of 21,500 years, statistically overlapping with the previous findings. 3 different scientific methods, each with different variables, different principles, and different potential weaknesses, all pointed to the same conclusion. Humans were present in the Americas over 22,000 years ago. If they didn't walk through the ice, how did they reach the continent? The answer lies in a migration theory that had existed for decades but lacked definitive proof: the Kelp Coast Migration Theory, also known as the Kelp Highway hypothesis. During the Ice Age, sea levels were dramatically lower, exposing a long chain of Pacific coastal land now submerged beneath the ocean. This coastline was rich with kelp forests, one of the most productive marine ecosystems in the world, providing a reliable food source of fish, shellfish, seals, and edible sea plants. Instead of adapting to new climates, terrain, and food sources, early humans could have followed this continuous coastal environment by boat, moving southward from Alaska towards Chile and beyond. The footprints at White Sands, preserved deep inland, finally connected the dots. Humans arrived early by sea, moved across the continent, and were thriving long before any land passage opened. For indigenous communities, this discovery was not a revelation, it was a confirmation. Many tribal histories speak of ancient ancestors who lived on this land since the beginning of memory, not since the melting of ice. Archaeology had long hesitated to validate these timelines, but White Sands left no room for doubt. A footprint changed the story, not an army, not a monument, just a step. And the message of that step echoes forever. Humans did not wait. They explored, they navigated, they survived, they arrived far earlier than we ever imagined.